I hope you enjoyed your break and could refresh all of the components of the consumer devices ecosystem. Let's go to the next step, to the rules and players, so from the real world, from the market, and also to the security aspects. All the rules and players and examples, so from the consumer devices ecosystem. Okay, this is the list of the marketplace for the remote SIM provisioning in general. So currently GSMA counts more than 90 players or major industry players to support the initiative. There are also smaller companies, they are all supporting this eUSSC concept, and it's also growing. So they're especially so in the not only the operators, but in general. Okay, now you can see on the list, so there are two companies which are actually not member of the GSMA but still participating in this. What can be different? So there's companies from California, so Apple and Google. So they're also participating in this initiative. Okay, who are the eUSSC manufacturers? Actually, we have on the list so the classic USSC makers, so like G&D, IDEMIA, Gemalto, and now Thales, the ST and Valid. So they're also defining the technology and working in the group actively. So the others are, so it's not the only list for sure. That's acting as a eUSSC manufacturer as well. Some other companies, chip vendors, for example. This is actually a really general overview. So for the data preparation, so we have Truephone, ARM, Ericsson, and yes, again, so we have an interesting combination. So that some former USSC makers, they now act on two sides. They don't. They are not only producing the manufacturing, so act as a USSC manufacturer manufacturing the eUSSCs. They have also the server side covered by the same company, and then it's easier for interoperability and complicated. Then so the eUSSCs from one entity and the so one company, and the server side SMDV Plus is from the other entity. Okay, device manufacturers. Actively working, Microsoft is leading the technical group, so defining the technology in the GSMA. So yes, as I said, we have Apple, Google, Huawei, and other companies. So I don't see them now on the list, but yes, Samsung, it's not circled. Yes, sure. And also other companies as well supporting this technology. These are just my examples. Sorry, so you have probably seen this implementations on the market, like so the Apple Watch and Samsung Gear. So you have all of it definitely on the market, and Microsoft, especially with the Microsoft Surface containing the eUSSC. The operator can be a mobile network operator, a mobile virtual network operator, or any other service provider. This is why we have this general term of operator. In the first versions of the RSP technology specifications for the M2M, so we had only the M and O. Yes, and for historical reasons, the SGP22 uses the expression operator. For the entity in the architecture, and this endpoint for the specific interfaces. The interface, so the specific interface, even though the more generic expression service provider, operator / service provider might be more appropriate. Yes, but the exact work split between an MNO and MVNO and any other service provider is irrelevant for this specification. Yes, and overall activities are covered by the architecture and the operator. And here in this picture on the left-hand side, we have plenty of operators working on this technology, supporting this technology. Certificate issue. Okay, again, this is the GSMA, as similar as the M2M world. So, and GSMA has selected the PKI providers to act on its behalf as a root certificate issuer. There are companies behind. So actually, again, as similar as before. So before I was talking about the companies providing the service, but who is using the service and has asking for, so one of this, for example, a service provider, so actually the one of the manufacturer of the SMDP Plus. So to download the profile, so it can be any company, so it depends on the contract. So then it's actually the company acting as a SMDP Plus, but the manufacturer of the SMDP Plus is, yes, one of this on the list. Okay, the partners for the certificate issue are the DigiCert for the consumer devices. We have the DigiCert, and you can download the CI certificate from its site. So here you can see the links. The server manager for the discovery service. So actually, subscription manager, sorry. The GSMA root discovery service is a globally available internet service, okay, which acts as a central communication point for eSIM-enabled consumer devices, allowing them to acquire profiles destined for them on demand. Okay, so we have the discovery service, and the root authority is actually also deployed by GSMA, provided by manufacturer Thales. The idea for subscription managed discovery service eliminates the need for other methods such as activation codes or primary device side loading, meaning little end user interaction required. The service is built on the SMDS entity described in the GSMA remote SIM provisioning, technical specification, and architecture specifications. Yes, the GSMA root discovery service is available now, having been launched in September 2017. Okay, so we have this root discovery service. This is actually the active service you can use. The connection of SMDP Plus and alternative SMDS entities to the GSMA root discovery service is via contractual agreement. Connection of LPA entities, LPAD and LPAE, to the GSMA root discovery service is free. However, to ensure correct operation of the DS service, mandatory interoperability testing is required via customer test environment (CTE). So there is a set of tests that have to be done for the just to ensure that this is working at all. The GSMA's interoperability test plan will be supplied as part of the application process. Yes, the access to the DS service via fair use policy. And who can apply for this? The SMDP Plus providers, the alternative SMDS providers, and the operators running their own SMDP Plus or alternative SMDS. Okay, this was a short overview about the roles and players on the market, or basically the manufacturers. So the functionality can be used by the different players. And I'm sure you have your own examples from your systems, how it will be used. Let's go to the next step. Take a deep breath, and we'll go to the security aspects of the system. Okay, we'll talk about the keys, certificates, and the algorithms. You remember this picture for the GSMA PKI infrastructure. So this picture splits the PKI architecture in the kind of three parts: the governance parts, so with a policy authority specification ruling over this, the technology part, and the operations part. So we have the two certificate authorities, so the sub-CA and the root CA, so meaning the EUM, at least in the current specification of the consumer devices, the only one who's acting as a sub-CA. In the future version, there will be more sub-CAs in the consumer devices world. And then we have the other parts directly issued, or only issued by, certificates only issued by the APA authority. Okay, let's take a look on the hierarchy. First of all, we have the GSMA CI certificate. GSMA CI certificate is acting as a root of trust or trust anchor, so the root certificate inside, so it can be inside of the EUSSC or subscription manager, and used to verify validity of the SM or EUSSC manufacturer certificates. Okay, this CI certificate, so you can see in the name, so we have the certificate CI, certificate of issuer, ECDSA. ECDSA shows that we are using the elliptic curves in the whole, in the end-to-end ecosystem of the consumer devices. Yes, So it meaning so the certificates are signed by this ECDSA algorithm, and the private key so is stored in the GSMA CI secured services. The public key is a part of the CI certificate. So the CI certificate is self-signed. Okay, we have the certificate set.ds or out or DP plus out. The ECDSA, yes, this is the algorithm. The server certificate is used for server authentication, basically. So both entities have the specific certificate signed by the GSMA CI used for the authentication. The private keys are stored inside of the secured area of the SMTP Plus and SMTS. Additionally, it's different to the MTOM world, we have the DPPB, or Profile Binding Certificate. Again, signed so using the CDSA algorithm. This is only valid for the SMTP Plus because it's used for the profile binding. So this, in this case, so for the encryption of the profile, so the different certificate is used then for authentication. And both entities, so SMTP Plus and SMTS, have its own server certificates for the TLS establishment. So the connection between the between SMTP Plus and the LPA is secured by the TLS protocol, or between the SMTP Plus and SMTS. Okay, then we have also the chain of the EUM certificate, yes, used for the client authentication, and the EUSSC certificate. Let's take a look. We have the security settings for the consumer devices in the EUSSC, so this is now important to understand. Again, similar as with the end-to-end world, so we have some trust anchors stored inside of the different components to verify the to establish the communication, and this trust anchors is used to verify the authenticity of the keys of the specific entities, verifying these public keys, meaning this key pair is really belonging to the specific entity. And the certificates will be received only by the certified authorities, so certified SMTP Plus, SMTS, and certified EUSSC manufacturer. So meaning the CI, GSMA CI will check if you're a certified entity and then issue the certificates. So, and to be a certified one, we'll talk about these details later, but this has to be very secure. We have this trust anchor inside. So in the EUSSC, we have this trust anchor. This is the CI public key. This is pre-stored by the EUM inside of the EUSSC. And this certificate is used to verify if the according certificate of the SMTP Plus or SMTS is authentic. Just imagine the situation when we have the different keys, different trust anchor inside of the EUSSC, for example, so the production key or whatever, and the real SMTP Plus. Then they will not be able to communicate because you will receive the security error. Okay, so it's important to have the same certificate, or for the test purposes. For the test purposes, we use test certificates. They are only inside of the test devices, and they are they're not rooted to the GSMA CI, so at least in the test specification. And then if you have the device with a test EUSSC inside, so it has a test anchor, trust anchor, so the test CI, and then so it can be only communicate with a test server, so having the same trusted anchor inside of it. The secret key of this specific issuer, so this secret keys of the EUSSC is called ECASD. So this is the security domain side of the EUSSC responsible for all the cryptographic operations. So, and then we have the ECKA, so elliptic curves cryptographic agreement or key agreement. So yes, this is a private key used for EUSSC authentication and key establishment. As you know, in the key agreements, we use this private key of one entity and the public key of the other entity, and then it helps to derive the keys, the symmetric keys. And then we have the keys to encrypt. Okay, then there is also a specific certificate of the EUSSC. So for the EURC authentication key establishment, here it is stored in the EURCC. For the operator, nothing changed. The same as for M2M world and the same as before. The operator can perform several operations on the active profile, and so performing this operation. So that sometimes the operator keys are needed. So it can be the SCP-80 or SCP-81 keys. Yes, and these keys are different. These are specific operator keys which are stored inside of the profile, and this keys can only be used by this specific operator while the profile is active or enabled. So these keys are not explicitly belonging to the remote SIM provisioning. So it's always as before, the OTA communication, over-the-air communication, and yes, the interface is the same. So you can do the remote file management or application management, perform this commands, procedures, and this is the keys used for this part. The platform settings on the SMDP Plus and SMDS configuration, so server settings. We have this, again, we have this trust anchor on the server side, otherwise the communication is not working from the security perspective. And so there will be no encryption, so it will stop. And we have the CI public key as a trust anchor used to verify validity of the EUM or SMDS certificate, depending on where, so to which entity the communication started. We have the DP out authentication certificate of the SMDP Plus. Okay, this SMDP Plus certificate is used for authentication key establishment during the profile download procedure, the first step. Actually, we have the authentication step on it. So this is the server authentication actually. The server authentication is also used, so I will come back to this later. Okay, so there is also the PB certificate, the profile binding certificate inside of the SMDP Plus. This is typical only for the SMDP Plus, not for the SMDS, because there is no profile binding on the SMDS. Because there are no profiles. The SMDP Plus certificate for the key establishment profile encryption itself, actually. So again, it's another certificate than for the authentication. For the authentication, so there is a specific SMDS certificate and key establishment. And yes, then we have also the TLS certificates for the server certificates for the TLS establishment. This is a regular TLS procedure, as you know it already right now, used everywhere. Yes, but then there is also TLS, so one side, so TLS server verification, server certificate verifications from the side of the server. So because on the LPA side, so the LPA verifies, so the TLS establishment is between the LPA and the SMDP Plus, or yes, between the SMDP Plus and the SMDS. Okay, why it is the case? Okay, this is the case because we have the LPA settings, and there is only this as well, this trust anchor to verify the server certificates. And so it doesn't, the LPA does not contain the certificate of the so the LPA does not contain the certificate of the device, so the LPA certificate to be verified by the server, because sometimes it's not possible. So there are some technical reasons for this. So there is no certificate. What else do we have? Oh yes, EUM certificate. Certificate is issued to the GSMA CI accredited EUM that can be used to verify user certificates. It's used again to be so this certificate is verified by the root CI. Okay, before we start with the summary, so I just want to emphasize some specific points, and especially so just I think it's important because sometimes you see people who are still mixing all of the different keys. We have different keys inside of the RSP ecosystem. We have this keys to be used by the operator, for example. So the operator keys to connect to the network. So we have this classical network access keys, so to be used with a millinage or TUAC algorithms or whatever. So then to connect to the network. So network keys, they're part of the profile. Another part of the profile is their OTA keys. So mentioned in my slides as SCP-80 keys. so inside of the profile, for the operator to perform some specific remote file management or application management. Yes, and then there are keys and certificates, which are basically, so you remember this picture with the keys on it. And yes, these keys are typical they are required for the remote SIM provisioning. By the way, in the consumer devices world, so we have only the classic X509 certificates to be used, nothing, no special format. And yes, elliptic curve cryptography. Yes, these specific keys are used actually for the specific securing the profile and transferring this to the USSC and for the authentications procedure steps. Okay, I hope you can have a brief understanding, a general understanding of the technology, and I hope so you get more and more familiar with this basics of the consumer devices technology. So I have a few questions for you to keep in mind, some aspects to test yourself, test your knowledge. So, and to check if you paid attention. Okay, first question, how many certificates are used in the consumer devices architecture? Okay, next one. Okay, which certificates are important for the USSC or used inside of the USSC? Which certificates are needed for authentication? That's all. So take your time to repeat it. Hope you enjoyed the training. So the third part, the consumer devices part. Some good news for you. So because all of this parts of the system will be way more complicated in the next version of the consumer device specification, which is already in progress. So get familiar with this right now, because otherwise it's very difficult to catch up. Yes, the details to this are, so actually to consumer devices world, so they are part of the training on the advanced part, consumer devices, but now we are good to go with this basic setup. Okay, let's take a look on the agenda. So on the first part of the training, we went through the general topics. Why do we have the eSIM? There are two different solutions and concepts from GSMA. So trends and deployments in the market and the profiles. Then the second part was about the M2M architecture and the security aspects. And now that we went through the third part about the consumer device architecture, its security aspects. In the next part, the last part of the basic training, we'll talk about the international standards. So basically the GSMA, SimAlliance and ETSI. Well, it's not called SimAlliance anymore, but it was started as a SimAlliance. And we'll talk about the certification procedure. So I hope you will, so I can welcome you in the fourth part of the training. And so you will get familiar with which specification actually to read, and what is the most recent version of the specification, and how to certify my product. Thank you very much for your attention. Hope you enjoyed it. I would like to welcome you soon in the last part of the training. Bye. Thank you.